Welcome to the Introduction to iPhone Development here on TechPub with Ben Sherman. Today we have episode number 4, which focuses on animations. Now, if you've ever seen one of the iPhones, ever used one, you know that the UI is pretty good with animating things. In fact, that kind of behavior is expected in just about every iPhone application. Well, today Ben shows you how to animate various elements on the screen, sending squares flying all over the place.
Okay, so let's do a little demo to talk about UI views and animations. I'm going to create a new project in Xcode. We're going to pick view-based application again. This time we're going to call it squares. And if you remember, this just basically gives us a basic project that will have a plain dumb gray view. Okay, so that's not very nice. Let's go ahead and clean this up a little bit. And we'll go into our squares, not our squares app delegate, we'll go into our squares view controller.m file. So this is the view controller that was built for us. And we use this little shortcut key to go full screen. And there's some commented out code in here like we saw last time. The one we want to implement right here is called view did load. So we'll uncomment that. This is where you'll add any customization you'll want to do on your view elements themselves. And the constructor is not a good place to do that because the view elements haven't been created yet. So since our user interface is going to be loaded from a nib file, after the nib is loaded, it'll call view did load for us. So right here I can say self.view.background color equals, and then we can give it a new color. And there's a bunch of static methods on the UI color class that we can call color with RGB alpha. So I'll do that, and I'll do 3, 6, and 9. And so 1.0 being the highest value you could put there. Alright, and let's save and run that. Alright, so we have a nice blue background. So next I want to add a few buttons at the bottom of the screen, and we're going to do that in Interface Builder so they line them up neatly. So we're going to select a file in here called Squares View Controller. These are the ones that they created for us, and there's 3 of them. There's the header file, the implementation file, and the nib file. So we'll open that, and Interface Builder will load for us. Now again, things are a little cramped in here, but we'll try and fit them. So here we are in Interface Builder, and I'm going to drag a toolbar down here at the bottom. And the toolbar is going to have these bar button items, and I want 3 of them. So let's go ahead and drag 2 more on here. Now there's different styles that you can have, some built-in things, and there's add, edit, done, yada yada yada. So I want one for adding. I want one for removing, so we'll use the trash for that one. And then I want this one just to say randomize. Now there might be a custom one that actually makes sense for whatever application that you're doing, but I'm just going to call mine randomize. Now I actually want these to be centered appropriately, so I'm going to create a flexible space here and here. So that should center it appropriately. Okay, now I'm going to hit save, and if we go back to our view in Xcode, run the application, we should see our toolbar here at the bottom. Now of course if we click these buttons they don't do anything yet. So let's wire that up next. So I'm going to go back up to the header file for our view controller. I want to create those 3 actions that will get called as a result of tapping one of those buttons. Now remember from last time, you're going to create 3 void methods, but instead of saying void, you're going to use this little marker IB action so the Interface Builder will pay attention to it. So we're going to say add tapped, randomize tapped, and remove tapped. So those are the 3 actions that we're going to respond to. Now flipped back into our implementation file, I'm just going to paste these right in here. And we're not going to fill in anything just yet. we're just going to wire them up, make sure they're working. So let's create a log statement inside each one. Add tapped. Randomize tapped. And remove tapped. It's always a good idea to sort of create the shell of the things that you're working with, and then go into Interface Builder, make your connections, test out the buttons, and just make sure everything's working, because later on you might get further down the line and forget to do it. Okay, so now that we've created our method body, we can build, make sure everything succeeds. We've got our IB actions ready. Let's go back into Interface Builder, and this time we're going to drag from the button. So we're going to hold down Control, click and drag, and notice it didn't actually highlight File Zoner, and that's because I wasn't clicking on the button. Sometimes you have to click twice so that it'll give you focus on the button. And if you're confused of which one is selected, you can always go up here into the Attributes window, go into the Identity Inspector, and make sure that the class is correct. So we're looking at a bar button item. So now we can click and drag, and now we get our actions that are appropriate. So we're going to use that one for add tapped. For randomize, we're going to go over here and pick randomize tapped. And for the trash can one, remove tapped. Okay, remember to save. Go back into Xcode, and let's just run it. And here we are with the view. Same thing we saw before. In fact, we can't even see our log statements yet until we bring up our log window. To do that, you can start off with Command-Shift-R. And I usually just leave this running so we can actually see the log events as they happen. Okay, so now we're ready to go. So what I want to have happen is when you click Add, or tap Add rather, I want it to add a square to a list and render the square on the screen with some random size and color. So the first thing we need is an array to hold these squares or views, and I'm going to create an NS mutable array and call it squares. Now remember, we have to define this in the header file between these two curly braces to define our instance variable. Then flip back into implementation file somewhere here. We can do this in the constructor or in the view did load. We're going to create it. So we're going to say squares equals NS mutable array alloc init. So since we alloc and init and we're hanging on to this for the life of our application, or the life of this view controller rather, we're going to head on down to the dalloc method before the super dalloc, and we're going to release that array. Now any objects that we put inside of the array, remember from last time, will actually get retained. When we call a release on our array and it gets deallocated, it's actually going to go call release on all the objects that it's hanging onto as well. Okay, so at this point we're ready to create a new view. I'm going to create a new square view. We're going to call it UI view alloc init with frame, and we have to pass in a frame, which is going to be an instance of CGRect. So let's create one. CGRect make, and it expects an X and a Y and a width and a height. So what I want to do is just set up all those things ahead of time. Int X equals, and we're going to call a method that doesn't exist yet. Random int between 0 and then the width of the screen is 320 pixels, but we do have to give it space to allocate for the width. So if I want to have a square with a max size of 40, then the largest I can put it in the X range is 280, because 280 plus 40 would be 320, and that square would be on the right hand edge. So then we're going to create the Y, which is the same exact thing, except we have a little bit more vertical room. We have about 480 pixels tall, but minus the toolbar, which is about 40 pixels, minus another 40. So I'm going to say 400. In fact, let's give it a little bit more room. We'll say 390. And we can always tweak these numbers later. And we need to call the correct method, random int between. Okay, so that doesn't exist yet, so let's create that. I'm going to create a void, not a void, a method that returns int called random int between. First argument is an integer. Second argument is an integer. And we're going to call that one max. And here we can just say return. We're going to say random mod the min plus max. Now in this case below it's 0, but if we wanted a minimum of 10, for example, then we want to add that to the max so that the upper end is actually correct. Sorry, that's actually max minus min. And the reason is we're about to add on the end of this plus min. If we do it the other way, we actually get numbers that are too high. Okay, so we write this hairy code once and then we get a nicer syntax down here. Now we need the same for width and height. I'm going to say self random int between. We don't want it 0 because I don't want it to be invisible. We'll say 10 and 40. And height, we could do the same thing. Now I know I called this squares, but really this is rectangles because I want it to be able to show you different shapes. So we could use the same value for width and height, but I'm just going to randomize it here. So now we can say x, y, width, and height. Now we have our rect, and we can build our view. Okay, so our view, let's give it a background color of white. So I'm going to say square.background color equals UI color white color. So there's all these static methods on top of UI color that can give us known colors or ones that we define. So let's give it a white color, and we're going to make it partially transparent. So we're going to set its opaque property to no, and then set its alpha transparency value to 0.8. And what that's going to do is allow us to see if two squares are overlapping each other. We'll be able to see one behind the other. Now, I could just set this, but it wouldn't actually do anything. So setting opaque to no is actually a flag to allow transparency. And transparency is actually a little bit slow on the iPhone. So if you have something that requires a lot of transparency and a lot of animation, it could slow down the frame rate. And you probably see that mostly with animating the scrolls animation in a table view. If we have a lot of table view cells with a lot of transparent content, it can actually bog that down pretty heavily. So that's why there's a flag to set opaque specifically. Okay, so where are we? We have rect somewhere on the view with a width and a height, and we have background color of white, partially transparent. I believe we are ready now to add this to our view. So first I'm going to add it to the squares array because we want to hang on to it. Add object square, and then I'm going to say self.view adds subview square. So as you can imagine, views have subviews, and our UI view could have its own subviews. Okay, let's run this. So if everything went well, when I click this button, we should see some rectangles popping up on the screen, and I can create as many as I want. And it looks all well and good. Okay, so the next step is for when I click randomize, I want to actually generate a new rectangle. And so since I want to generate this random rectangle more than once, I'm going to copy this code. I'm going to hit Command-Shift-J, which brings up our refactoring menu. Now, the refactoring menu is a little cheesy if you're used to something like ReSharper or Eclipse, but it's nice that it's there. So I'm going to call that random rect. Hit apply, and it's going to automatically, well, doesn't do a perfect job, but you know, it does do the job. Okay, so we have this new random rect function, and the code we wrote earlier is now calling that function to get the rect. I'm going to clean this up a little bit. I can call self random rect there. Get rid of this. Okay, now when randomize is tapped, I want to say for UI view square in squares. You can also do a for loop with an index, like any standard C language, but this is usually a little bit easier to read. Okay, so now we have our square. I want to set the frame to a new position in the view. So we're just going to say self random rect, and we'll build that and we will run it. Okay, so let's create a few, click randomize, and boom. Now they're scattered all the way across the view. So here's where I'm going to blow your mind, hopefully. The iPhone SDK is, although it uses Xcode, which isn't my favorite IDE, and although it uses Objective-C, which at times can be a little scary, the real value, I think, is in some of the powerful high-level libraries that you have access to. And one of those things that Apple does really well is animation. And it's not to say that you should just use animation everywhere. In fact, the reason why they make it easy is so that you can use animation as a means of creating better user interfaces, where you might not use a pop-up dialogue to show that something's happened if you could just animate that thing happening. So let's take a look. We're going to call a method on UI view, the class called begin animations. We're going to give it a name called randomize. And context is just some data that we're going to carry along with that animation, and I don't really care about it. So then after setting the frame, I'm going to call UI view commit animations, build that, run it, and let's take a look and see what they give us. Hit randomize. Check that out. So if you notice, each one is animating its new position and its new width and height when I click randomize. Now it is going a little fast, so what I want to do is slow it down a little bit. So there's some options you can set. So right after the begin animations call, let's call UI view set animation duration, and we'll give it a duration of 1 second so that we can see what's going on here. Okay, so if you notice, you look closely at one of the squares or one of these rectangles as it's animating. Notice how it goes from a starting speed, accelerates to some peak velocity, which is halfway through its path, and then slows down again. And that's called animation easing. And that's a way that you can make your interfaces look a lot more compelling than just a flat, no curve animation that just takes the object, moves it as a constant velocity across the screen, and it looks very mechanical. This actually looks nice and smooth. Okay, let's quit that. Next thing I want to add is color. So right here we're hard coding it to white, but we can do that with another function here. So let's create a function that returns a UI color instance. We'll call it random color. And we'll create a float for the red, which will be random int between 0 and 255 and divided by 255. We'll do the same for green and blue. And now I just want to call UI color with red RGB. And right here we can put the alpha for the color value, which will actually control the transparency of the view itself. So we can actually clean that up a bit and get rid of these two lines of code. And instead of calling UI color white color, we're going to call self random color. And it looks like I may have a typo here somewhere. Nope, it succeeded. Okay. Sometimes when you'll notice when the Xcode's code completion doesn't work, you probably forgot a semicolon or something. Okay, so now when we call randomize, in addition to setting the frame, I want to set the background color to self random color, and let's run that. Okay. Let me click randomize, and now notice that they're moving to new sizes and new colors. And everything uses the same animation curves, and it interpolates the value between the two ending points. So all you have to do when you're doing simple animations like this is set up the beginning state and the ending state and tell the core animation libraries to do the work for you. And that's a very powerful thing. I'm actually going to make these squares a little bit bigger so that we can see them. Let's go 20 to 50. How about 60? And we need to turn these numbers down a little bit so that they can actually fit on our screen. Okay, that looks better. Okay, so the very next thing I want to do is when you hit the trash button, it's going to grab the first element in the array and remove it in some nice way. So we could just make them disappear, but that wouldn't be any fun. So let's go down to the remove tapped. We're going to do something special here. So we're going to grab the square from the squares array. Let's say object at index 0. And let's set an animation for that. So we're going to create an animation block by calling begin animations. We're going to give this one an ID of removal, and this time the context is going to be our square, and you'll see why in just a second. Somewhere at the end we're going to call UI view commit animations. Okay, so what I want to do is set the frame of the square to be somewhere on the bottom of the view, off screen. So we're going to create a new CG rect called off screen rect, and we're going to initialize that to the square's frame. Then we're going to update the y value .origin.y equal to somewhere off the screen. So it's 480 pixels tall. 1 pixel is just going to move it completely off screen. And then we're going to set the frame of the square to that new value. Okay, so if I run this, just test it out. Hit trash, and well, we didn't actually remove it from the array, so it's still trying to remove the same one. So we're going to say squares remove object at index 0 as well. So once we pull it out of the array, we'll remove it. Okay, and that works pretty well. It's a little fast, so let's slow it down. We can say UI view set animation duration, and we'll make it 2 seconds. So you can actually see what's going on. Now notice you can actually see the easing going on here. We don't actually want it to do easing at the end. It's like it's falling. We want gravity to kick in. So that animation curve is actually hurting our animation look and feel. So what I want to do here is change the animation curve to one of these constants, UI view animation curve, and we can change these. So I want to say ease in, which means it will ease into the top speed, meaning it'll start at 0 and accelerate to some peak velocity, but it won't ever decelerate, and that's what I want. The default is curve ease in out, which eases in and eases out. Now notice we're actually getting the exact same randomization because I didn't actually seed the randomized call, but that's fine. Another bug we have, notice that it's skipping. If I hit randomize in the middle of this animation, it's skipping. We can fix that going up to our other animation, and we'll say UI view set animation begins from current state. Yes. Now we still have a sort of abrupt halt in speed, but the squares stay at their same color and position and size wherever I click it. So if I click it close together, and then if I let go, they finish their animations. And now we can sort of drop these out of the sky. Let's do another quick effect on those dropping ones. Let's go ahead and change the alpha value to 0.3, so they'll fade out as they're dropping. And we have a very big problem with this application right now, and I'm wondering if you can guess what it is as I'm playing with this here. So notice that these things are actually fading out as they reach the bottom. So what's happening to all of these views that we drop out of the array? At this point, the array isn't holding on to them anymore, but the animation is. That is, until the animation is done. And so we actually never release these views. And that could be a very, very big problem, especially since we're creating lots of them. So that's why we set that up as the context of the animation. I can't erase or release the view right here, right before our commit animations, because the animation isn't done yet. And if we remove the view, then our animation actually won't do anything. You just won't see the view. It'll disappear immediately. So we need to wait until this animation is finished and then remove it. So that's what I'm going to do here. Before the begin animations call, I'm going to call UI view set animation delegate to self. And then I'm going to set the animation did stop selector to a method on my class that I haven't created yet. So we're going to put that right here. And this is one of those things where I have no idea what the method signature is for that, and you'd have to search for the documentation. But one thing that I found that is nice is if you hold Command and you double click on a symbol, it'll actually take you to the header file, even if it's framework code. And sometimes they're pretty good about putting comments in here, which says, so here's the did stop selector. They put a comment over here that says, hey, this is the method that you need to implement. And it's hopefully fairly obvious. Hopefully it's fairly obvious why I don't remember this by heart. So let's head back over to our code here. So now we have a method that we need to implement. Okay. So basically it's just, hey, it finished, and this is the animation ID, and I don't know what that number means. And then they also pass in the context for you. So what we're going to do is we're going to say if the animation ID is equal to removal, which was the animation ID that we set above. Now, since we're setting the animation delegate, this could actually get called for multiple animations, so we only want to handle this case here. So we want to pull out the UI view from the context. We're going to call remove from superview, and we're going to call release. And let's see. Oh yeah, we need to fill this in. So for the selector, you do @selector, and this is basically a method pointer. And I can say animation did stop finish context. So notice how when you refer to a method name, the method signature is the sum of all its arguments, but without the type information or the argument names themselves. So we have animation did stop : finished : context : and that is the uniquely identifying signature for this method. Okay, let's build that. No more errors. We hit run. Hit randomize a few times. And you can't actually see that being dealloc, but if we were to profile this in the memory profiler, we'd actually see that these guys are being cleaned up. Okay, so let's take a look at one other aspect of this animation that we can do. Is when we remove, instead of just falling straight and rigid, I want to actually rotate these a little bit. So let's create a transform. And there's all these CG affine transforms that you can do for translation, scale, and rotation. So what I'm going to do is create a rotation translation, and we're going to pass in the degrees here. So let's say we'll rotate 80 degrees, and we're going to run that. And notice now when they fall out, they're actually rotating. So that's pretty cool. And you can do this, these animations, I can hit this as they're animating, and everything just sort of works out. And it's a very powerful high-level animation library. So it looks like we actually have a little app here that we can throw on the App Store and make a few bucks. And we can call this the Modern Art Generator. And just maybe we can just add a few features for saving this as a picture or emailing it to a friend, which actually wouldn't be too hard to do. So one last thing, for the randomize, let's add a rotation for that too. For this transform, CG affine transform make rotation, and I want to use our random number generator. Random int between, let's say, 0 degrees and 180 degrees. So add a bunch of these, we hit randomize, and now check that out. Looks pretty cool. The performance is actually pretty good on this. When we get into the hundreds of views, though, since you can tell that the transparency is actually working, it will tax the GPU on the iPhone itself. Now, you might not see this in the simulator, so if I were to actually put this on the phone where it's actually resource constrained, we probably wouldn't see this type of frame rate because there's just too much stuff going on. So in this sample, we talked about how, again, to wire up interface builder elements to code in Xcode in a view controller using IB action and making connections. We talked about generating views and setting them with a CG rect for their frame. We talked about randomization for position, size, color, and rotation. And we talked about animation callbacks so that we can handle when these animations are finished, and we can dispose of the views that we're no longer using. So hopefully that gives you a little bit of an idea of what's possible, and in about 10 to 15 minutes you can create an interesting little demo app that you can show off to your friends.